Hello, my name is Mohammad Hamad, and I've done some operation that is related to the network security. First of all, I imported the libraries that are Python libraries, and after that, I selected a dataset that is bot IoT. And the next step is that it will choose the top 5 rows of the dataset to check its correctness, that it is not scrambled. As you can see from the output, it only chose the top 5 rows of the dataset. In second part, in analysis and characterization, it will check the protocol that are being widely used, whether it is ICMP, ERP, UDP or TCP, and it will check the size of the packet, whether how long it is or how heavy it is, because usually the tiny packets mean that there is a DOS attack. And there is also a value count that will check that which uh, packet is being usually used, whether it is TCP or UDP or whatever. As you can see from the poll, the TCP and UDP is widely being used and it is reached up to 1 million, and which means that there is a high chances of the TCP SYN flood or the UDP flood. On the second diagram or the flow chart, the packet analysis, as you can see a spike so far on the left, that means that it is overwhelming the majority of the network packet, and it is highly characterized to the DOS attacks such as TCP SYN flood attack or UDP attack. And here is also another example that there is a top 5 source IPs, and from which the 4 IPs that are widely being used, and it is also uh, compromise the IT devices and moving toward uh, some attacks like DOS attack. Now in chunk 3 we'll do a simulation. Basically what we do is to take a 200 rows from the existing dataset and we'll disguise it. We'll make it a malicious dataset that gonna be used by the attacker, and we'll differentiate two dataset that is going to be the good dataset and the bad dataset. And the next step is that we'll do a probe. In probe, we usually send our packets to the victim machine to see if it is there or not. So we'll make our 42 tiny packets and set port 22, the SSH port, and the most loving scanning for the hacker, because if they guess the password, they'll gain full access to the computer or whatever's PC or laptop. And after that, we'll merge and clean. We'll merge the board data set and see if there is any missing data or missing column. So if it is there any missing column, it will fix it. We have to fix it. It will show an error, and as you can see that the new data is generated. And then now the fourth chunk is started. Okay, the fourth one is the security principle, and the first we have used is firewall configuration. And in firewall configuration, it just act like the same way that the security guard is outside the grocery shop and he has the blacklisted people that are not allowed to enter. And the same way, the firewall has the IP addresses that are blacklisted and not allowed to enter the specific PC. So here in this condition, we have 10.10.10.6s that are not allowed to enter a specific PC. So if it appears, it will simply drop that packet. And the second one is intrusion detection system, and it has some specific criteria. If the packet is over 3000 bytes, or someone is trying to connect to the SYN flag to port 22, it will just make an alert. And the third one is the SDN. It acts just like a traffic cop. So any packet with the UDP protocol means that the UDP protocol, why? Because it is unreliable and used usually by like video streaming. No TCP acknowledgement are used. The three-way handshake is not used in the UDP. So if a packet with your UDP protocol and it is over the 1000 byte, it will just throttle and slow down for to check for the malicious activity, and if it appears, it will simply drop that packet. The back in chunk 4, you can see that firewall drops 200 packets because we have made a data sets uh, uh, which um, name as a bad data set used by the attacker machine. So when it is detected by the firewall intrusion detection system and SDN policy, it simply dropped it to 200 packets because the IP that is used is malicious and blacklisted. So now in chunk 5, we use the smart column standardization. Basically, it is an interpreter that knows everything about the packet, its uh, size, its protocol type, and its port number. So we just pick the important information that are related to this packet and drop the text like timestamp and the ID. And we'll now use the uh, model to train it. So we use the KNN, the K nearest classifier, which use the to check their neighbor and then vote, and we use the random files, which basically build to so many trees to and then vote, and we use the sport vector machine and then the decision tree. So you and we 70% we use for training and for 30% we use for testing. And here you can see from the graph that we have made here. See, for the Canon the accuracy is 0.999, and for the random forest the accuracy is 1.000, and for the SVM the accuracy is 0.998, and for the decision tree the accuracy is 1.000. And mm, the Canon it almost found the 7,000 5 lakh 77,984 which are correct on the top left, and for the bad it raised 441 false alarm. And for the random forest, where is the random forest, and for the random forest it was extremely precise, it only had 6 false alarm, and for the bad it also missed 4 attacks. And for the SVM, look at the bottom left, so it says 0, which this means that SVM did not miss a single attack, it had 100% recall. And the last one is the decision tree. So for the decision tree, the performance is the identical to random forest in this run. The like, yeah. So thank you.